Hello and welcome to Pixel-Geeks. We're a geeky duo obsessed with all things tech, lights and DIY. Pixel lights have exploded in popularity lately, offering endless possibilities for creating unique and captivating effects. But if you're new to the world of pixel lights, you might be feeling a bit overwhelmed by all the information out there. Fear not, we are going to create loads of videos to take you from zero to hero, providing the knowledge and experience for you to use in your own amazing builds. Firstly, we're going to cover what pixel lights are and how they work. Let's get into it. So let's first look at what a traditional LED is. We'll avoid any technical jargon like electrons and just keep this pretty simple. LEDs are like tiny, colourful light bulbs, as you can see here. They're made of special materials that glow when you send electricity through them. Unlike traditional light bulbs, LEDs are very efficient and can last for a long time. One important thing to know about LEDs is that they only emit one colour. This means that if you have a red LED, it only produces a red light. If you have a green LED, it will only produce a green light. So inside an LED, what happens when you provide voltage to it is it glows inside, and that is what produces the light that you see. The different colour it produces is actually down to the dye which is inside the LED. This is known as the semiconductor dye. So in a nutshell, LEDs are pretty simple devices. You have two terminals, the anode and the cathode, which you can see, and basically this is the negative and the positive for the voltage. You apply voltage to turn them on, and the amount of voltage controls their brightness. If you stop applying voltage, the LED turns off. You can also turn an LED on and off quickly to create a flashing or pulsing effect. And that is pretty much it. Let's move on. Now that we understand the basics of LEDs, we can move on to understand pixels. So just remember, apply voltage to an LED and it produces light. Take away that voltage and it does not produce any light. We alter the amount of voltage to the LED and it gives us a different brightness of light. Here we have three LEDs in the colour red, green and blue. This is known as RGB. You've probably heard of that before. So we can create a good number of different colours by mixing different colours together using RGB. Why we're showing you these LEDs in RGB will become apparent shortly. So now look at this RGB wheel. It shows you a colour which can be produced based upon what colours you mix. That's pretty simple, and you probably learned this with mixing paints at school. So this is a simple representation of what we can produce with RGB. We also mentioned that we can change the brightness or intensity of each LED. So what does that mean? So let's explain this in a different way. So let's use this RGB picker to visually explain this. Here we have red, green and blue color options. So firstly, look at our slider. Currently the color is set to 0, so you could think of that as no voltage, but we can go up to 255 on each color on red, green and blue, 255 being maximum voltage or fully on if you like. For now, we're going to say use color red at 100% and green at 100%. It gives us the color yellow. But then let's say we want red at 100%, which is 255, and green at 50%, which will be 127. Can you see that because we changed the amount of green, we now get a different color again? We now have this reddish orange color. So if we change the brightness of each LED using red, green and blue, it gives us even more different ways to make colors with our LEDs. So now a more advanced RGB wheel using different brightness of color, which gives us loads of options. But you're probably now thinking, well, how many different colors can we make? So in theory, if each of the red, green and blue LEDs can have 256 brightness levels or intensity, that would mean we can do the following sums. 256 times 256 times 256. That gives you over 16 million possible colors. You probably have seen smart lights advertised as having 16 million different colors. This is how.
So now we know how the different colors are produced. The next question is, how do you get each RGB to come on at the different brightness and when? We can explain that now, which ultimately explains what a pixel light is. So how does a pixel light work? Well, inside you have an RGB LED. As you can now see, the LED has a lot more legs on it than our basic one we showed before. Now we have legs for red, green and blue, RGB. And by applying different voltages to each of these will produce the resulting color we want. The brightness of an LED is controlled by varying the amount of voltage applied to it. We know this. Inside a pixel light, you typically have a tiny integrated circuit, IC, or microcontroller, often just referred to as a chip. You can see on the chip shown here, it has legs for red, green and blue, RGB. That is what attaches to the RGB LED and provides the voltage to each RGB leg. You will also notice that we have legs for data in and data out. So now we can look at how you tell the chip what to do by sending data to it. So now we can answer the question of how we tell each chip attached to an RGB LED what to do. And that comes down to a controller. This is responsible for telling each and every chip what to do. We're going to cover this in more detail in a later video, but just know that we need a controller. This is what does the magic between selecting what you want the lights to do in your app and speaking with the chips to make it happen. So let's look at the chip in more detail and explain its purpose. Firstly, it receives data or the instructions from the controller which we mentioned previously. It then converts that data into what voltage should be applied to red, green and blue to produce the color you asked for. And lastly, it drives the LED where the converted information sends the specific voltage to each leg on the LED. Each pixel LED typically contains 3 individual LEDs, which we've covered, so red, green and blue. These are arranged close together and are often packaged into a single bulb or pixel, including the chip, which you can see here. And here we have pixel LEDs. Aside from the voltage, we now have the pixel and how it works, and the controller which is required to tell it what to do. And that concludes our explainer of what a pixel LED is. I hope you've enjoyed that, and see you next time.